So as we begin, I'm going to first bring out that there is some documents that we're going to go over with the MPIO, bonding with Auto Failover, but let's just get right to the heart of it. There's this document that I'm sure many of you see. I'm not going to spend too much time here, but I just want to go over some overviews with it so everybody has a general understanding. If you look at, if you want to know where this document's at, it's in our support directory under libraries and how-to resources. There's a section about Auto Failover, and there you can receive this information. Okay. Now when you see this, at first you're thinking, okay, well there's a lot here. You have on the left here, you got RAID System 1 primary access, and then of course on the right here we have the data storage server DSS2. Now if you look, we have this is the general idea. Do you have to follow to the rule? No, but there are some constraints we would like to inform you about. We do get the tickets where we have some customers that are actually using one NIC to try to do everything on, and that's just not going to work. And the best is really to use two or more. We've seen some interesting cases where they're using the the volume replication NIC, which is right here, that's noted, and also for the auxiliary heartbeat, that they'll use that for the virtual IP address. Bad idea. So I'm basically going to go over some general overviews, and then we'll go right into the DSS setup. We do recommend that you do have more than two NICs, but in some cases the motherboard has two NICs, and you basically want a general setup. The best preferred is that you can get some additional NICs, maybe a quad port NIC, or maybe use 10 gig E, and use a 10 gig E for the volume replication. Now we show this going to two switches. This is the best possible scenario. But to save on costs on a 10 gig E switch, we recommend a direct connection. And that can even be with even directly connected to a 1 gig E as well. And InfiniBand, you can use that as well. Because we treat InfiniBand as a NIC as well, so it's IP over IB. We do have connection mode as well, and we are working on some of the other protocols. But for right now, you can go ahead and utilize that function. So when you see ETH1 right here, that's dedicated for your volume replication. I don't like to see, when I see tickets in, that they're using that NIC that's dedicated for volume replication. I've seen it used for all kinds of reasons, even for NAS functionality. Try to keep that dedicated. NICs are very inexpensive to use, and if you've got a lot of volumes and a lot of data, a 10 gig E is very affordable if you're directly connecting to another DSS system that is what we call sistered. Now, of course, if it's over a WAN, and then obviously you're going to need a switch and be able to have that WAN pipe large enough. Obviously, you can use the web GUI management for either NIC, even the ETH1 and even your bond if you need to manage the GUI. But in some cases, we do select for security reasons to have ETH0 dedicated for the web GUI management. Now we roll into what we show here is a bond. But keep in mind that ETH2 and 3 here could be used for MPIO. And pretty much we've seen in the past that, a lot of the bonding is used, especially with VMware and Microsoft, but mostly we see bonding used for NAS functionalities. That's with many hosts connecting to the NAS shares. So if there is some instances, we pretty much recommend to use MPIO. Now MPIO, what we're going to do is these will not be bonded, E2 and E3. They will each have their own IP address. And then we create a virtual IP address for each of those NICs. So bear in mind that this is just a general overview of best practice, but you can really do some dynamic effects on this. You can even use a bond, put a virtual IP address on it for your NAS NFS Auto Failover, and you can use MPIO at the same time for your iSCSI with VMware. So let's go right into setting it up on the two DSS systems I have on the screen. Here on the left, you see this window here. I have a DSS source. If we look at the last octet here, it's 221. And over here on the right, I have the DSS destination. And that will be the third octet. Will be this IP address will be 222. We go right into it. We're going to go right into setup network interfaces. We're going to go into start off with the source first. If we scroll down, we get all the way down here to create bond interfaces. We're going to start off with the bond first. Now, when I have right now, I have a 10 gig E, which is servicing for my volume replication, which is totally dedicated. That's on ETH2. I'm sorry, the ETH 1 and 4 are for my dedicated. If we look here, we go to volume configuration, volume replication, and we'll see that I am using, if we look at the second, and actually we'll just go through the whole IP address so everybody has an understanding, 192.168.5.222. And of course I have, that is pointing to the DSS destination server on this side. Okay, so if everybody gets up to speed with me here, and that way we can move forward, that way I'm showing that this is pointing back over to the source, and that is dedicated as my 10 gig E NIC. They're directly connected. I'm using the Intel 10 gig E. There are other 10 gig E NICs that are approved by us and certified, and we do have the drivers for it. All right, let's go back into the network interfaces. And when we're bonding, we want to make sure what type of bond we want to use. So, and before you bond, I want to talk about jumbo frames. So let's just go over this, and then I'm going to go right into the jumbo frames, and then we'll go ahead with the virtual IP address settings. Now, if you look, I've got several different NICs here. If we click on the down arrow, this gives us information about the NICs. And here you'll see the type of NICs. Now, why am I doing this? Well, I have seen in some cases where some customers will use mismatch of chipsets of 1 gig E's. Although it may work, there has been some timing issues and some issues related to between the chipsets that cause some instability. So when you create a bond, I want to make sure everybody understands, try to match the chipset. If you just click on this arrow down here, it'll pull it up, and you'll see that you have the Intel Corporation NIC here that has the 82576, and of course, you probably want to match one that is similar. When you create your bond, you want to be able to select those NICs, and then of course, select your NICs, select the bond type. Now typically what we see in the industry is typically mostly balance RR and 802.3 AD. Active load balance and then TLB and the balance XOR broadcast, you can find more definitions, and that's on another topic section. But typically if you want to find information, you just click here on the question mark, and we provide all the information of what each bond mode provides. So you need to, probably the best thing is to test, but typically most receive the best performance values out of 802.3 AD and balance RR. Now on 802.3 AD, you are going to need a managed switch that supports what we call LACP, Link Aggregation Control Protocol. And there's typically two types, there's dynamic or static. Most of the VMware setups are typically, they're at static, and so you want to be aware of that and you want to test that. Here we're using dynamic. So bear in mind to test which bond works for the best for you, and then of course set your bond up. When you set your bond up, I see a lot of cases and tickets where you want to set your jumbo frames. Before creating your bond from your NICs, from usually the same chipset, access the console screen. Pretty much a lot of you already know the console screen already, so I'll just go ahead and pull this up. And I've already logged in, so a lot of you already know how to set it up. Where you want to go at this point is a tool in the hardware tool sets, which is Control-Alt-W. If you don't know which of the functions to go to, just F1, and you'll be able to see all the functionality of each interface, of tools you can use, like Control-Alt-T for ping and so forth. So here's the hardware configuration under Control-Alt-W. We're going to use the GUI password to get in. We go into tuning options, and in tuning options, we want to select the jumbo frames config. Now here it's already mentioning that we already have failover. We'll have to stop the failover. I did this purposely because we had previously allowed people to actually change the jumbo frames while the auto failover was in function. And that was really not a good thing. So we basically modified that and changed that you cannot enable the jumbo for be able to modify the jumbo frames while auto failover is enabled. So we're going to go ahead and stop it. And of course, obviously, if you have connections, your virtual machines or your initiators that are connected to the virtual IP address, be aware that they're going to be disconnected. So it's best to stop your virtual machines if you're going to make these changes to these values. All right, so once you get in, now you'll be able to change the values. Make sure if you've bonded, let's say ETH1 and ETH2 together, that you want to set the jumbo frames to your size. Make sure with your manufacturing vendor, the vendor, that what specifications they ask for. Some are 99,000, 901, 9001, 99,004, and so forth. Make sure you do your research to find out which values are correct for your network interface card. So here you want to make sure that both of the NICs are set and that they are matching the same. Okay, so once you've done that, and then of course you want to set your bond. So you would want to set your bond to the same value as well. Once you've completed that, you've hit apply, you're ready to go. And by the way, make sure to do this on both servers. That goes also with any changing of the iSCSI target settings. We have seen cases where in previous releases, now you can't do that in the new release. But if you did a change in, and probably going off the subject, but if you're going in to change the target settings, changing the max receive data segments and things of that nature, and you only do it to, let's say, the source here, but you do not do it on the DSS destination side, you're going to have problems and it won't even perform the auto failover service. So this goes as well as the jumbo frames. Make sure both are set exactly. So you want to set the NICs and you want to set the bond. Okay, now you see we've created our bond here. We selected, in this case, we did a balance our R for this bond. We've given it an IP address. If you notice that the IP address that's coming up here is set to a 192.168.10.221. I kept the matching scheme. I like to keep my IP addresses in order. So here the third octet is 10.221. At this point, you can see where I'm using a balance RR bond. And then now on the bond on the left side, you'll see right underneath the failover bond 0. Now on the bond 0 that I have, I want to make sure that I'm enabling the virtual IP address. So we're going to set this to 7.10. I get a lot of questions that people have asked, is it safe because we have this error, this message that warns us, is it recommended to set a virtual IP address that is different subnetwork than the physical and virtual IP address of this machine? All right, we do have other NICs that are going to be on the 7X. It is okay as long as you don't have duplicate IP addresses. You can even bust up the subnet mask, so you can do it instead of all 24 bits, you can change the value. Here I'm just going to take all 24 bits, so you can do a 248 at the end, and you can have multiple. You can do either way. I just get a lot of questions, people asking, is it safe? And we will update our documentation on the website that shows otherwise. So here, every time you're able to enable the virtual IP, you want to make sure that you have the auxiliary connection enabled as well. So again, disregard this message that comes up. It's okay, as long as you don't have duplicate IP addresses and you don't have an IP conflict. Now we want to set it also on the destination side. So you want to make sure that your virtual IP addresses are the same on the source as it is on the destination. And also you want to make sure your auxiliary connection will happen. Many times we catch this where people are not able to set the auto failover because they didn't enable where they're using the virtual IP address, they also have to use the select for the auxiliary. So keep that in mind. All right, let's go back to the source. And now, before we enable the auto failover service, let's go into MPIO. Basically, you want to select two NICs. Do they have to be the same chipset? Not necessarily. But you want to be able to keep, obviously, between 1 GbE to 1 GbE and not mix match them from 1 GbE to 10 GbE for obvious reasons. But basically, with MPIO, we have selected the NICs here that we're going to show. We're going to use E3 and E5. So here, let's look at our IP address. We're using 4 for this one, which is the same chipset, 82576, and we'll select 5, so which is a .6221. So let's take a E3. We'll set up our virtual IP address, and we'll also get ready to do it on the secondary system. And here we're going to use 192.168.7 and of course .10. And of course we want to use the broadcast address of 7.255. And of course we're going to enable the auxiliary connection. We're going to do this. Hold on 1 second. There we go. I want to use 11. So we give you a little warning because 10 was already in use because we had bond 0 on there. Okay, so we're going to take this and go to 7.255. And now we have our virtual IP address for our first NIC with the MPIO. Obviously, we're going to apply this to the auxiliary connection. Now we're going to go ahead and do E5. And this time we're going to set it to 7.12. Put our subnet mask in. And of course, our broadcast address, we're going to 7.255. And we're going to enable our auxiliary. Now we have to make sure that our destination server has the same values. So we're going to use 7.11 for E3 and make sure our auxiliary port is enabled and go back to E5. And so while we're doing this, just keep in mind that MPIO allows a server with multiple NICs to transmit and receive I/O across all available interfaces. So this also corresponds with the MPIO enabled server. So let's go ahead, and now we're ready to start our auto failover service. Now what I'm going to do is I'm going to be selecting, like I did iSCSI volumes. Here I have just 2 iSCSI volumes. One I'm probably going to be designated for mostly for MPIO. I set some allow and deny values on it. And of course I have a NAS volume. We're going to enable our auto failover. I'm going to use broadcast here as my destination server, 1.222. And of course, I'm just using a ping node. I can have more than one ping node, but for this instance, it's fine. Typically, it's best to have, I would say, 2 to 3 ping nodes. You can use everything from a router, a firewall, even the Vmware server. Something that has a greater uptime value, like a switch as well. And then we'll go over to the secondary system. Hit apply, and of course we have our primary node set to 1.221, and we have for broadcast, and it correlates with the ping node. Okay, so now we're going to, you'll see that the start button, if you're using NFS, make sure that you do have the product key enabled on your system. and also to mark both of them if you have NFS and iSCSI volumes being replicated. So we'll go ahead and hit apply on that. And we do have a capability. Many questions come up. What happens if I create a volume replicated task that's in the task manager here while I'm running auto failover? There is a small update that allows you to do this. It is a feature not yet developed. I will be having a webinar on this and how to demonstrate how that is done. But we do have a small update. If you email our support team, we will be able to give you that small update so you guys can basically perform that without stopping your virtual machines, without stopping the auto failover. So this small update will allow you, if you had tasks residing on the other side here. Okay, let's go ahead and start our service. Let's give that a few seconds. This is the process where it's configuring both nodes. Basically what it's doing is checking the values, making sure that the auxiliary ports are set for each of the E3, E5, and Bond 0 for both sides, making sure that the virtual IP addresses are able to communicate on the network, checking the ping node. So there's a lot of things that are going on right now that basically are locking down with all the auto failover mechanisms that we have. Now, why this is coming up, so again, what we're going to use is Bond 0 is going to be for NFS, and for the MPIO, we're going to use E3 and E5 here, and we're going to bring up the VMware server so we could show you the values of using the Bond. One of the things that we made some adjustments in tuning, by the way, is what's called IR detection. And I want to bring everybody to this. We've already connected. I'll show you that in a second. This is really important to have enabled. We released this a couple releases ago that if you had errors on the RAID controller, such as 2 drives failing on a RAID 6, this would automatically fail over. So in the previous versions, we didn't have that feature. Now we do. So it's a good one to make sure that you do click on that trigger failover on I/O errors. We've had some great success working already with that. All right, we basically have both servers are in an auto failover configured mode. It's successful. What we want to do sometimes is verify right up here in the global status. Service is running okay. Primary is active, and the secondary should also be ready as passive as we see right here. So we want to see the status for the failover services that are on for iSCSI, NFS, that the communication between ETH0, Bond 0, the ETH0s are used for the storage community, the primary and secondary nodes. Bond 0 has the virtual IP address for NFS, that's what we're going to be primarily using it on, and as well as the auxiliary, and for MPIO, E3 and 5. Let's go right into my VMware server here. What we want to do is, I basically, just in case I want to bring everybody up, what we're going to do is add a storage. We're going to start off with the NFS. Here I'm going to specify the Bond IP address. And of course the share. Now the share name, just in case you want everybody to bring up speed, is if we take, go back to the DSS, and we look at the share on the primary server. I've also restricted others from accessing the system. I want to be able to dedicate this. I use allow and write access. And if you notice that there's really nothing else I can do here. Previously, all the services were available. Samba services. Once you enable NFS auto failover, those services are gone. So bear in mind that once you make a set for a share to be used, you want to dedicate that NAS volume for that share only for NFS. Data replication can be used. Currently the agent is off at this point. If you look at the destination for its share, for the NFS share called test, it'll clearly identify it. There's really nothing you can do. It's restricted until you fail over, then you'll have access to it. Okay, so let's put here what we want to do is do a /test for the share name, and we'll just give it a data store name. And here you can see that we are connected to the bond via NFS and selected the IP addresses you can see right here. Okay, now let's go into MPIO with the iSCSI target that we've created. What we want to do is go into the storage adapters, scroll all the way down until we see the iSCSI software adapter in VMware. Here we have I set my parameters in the properties for my Vmware Initiator. Let's take a look at that. So I've entered the virtual IP addresses for E3 and 5 that we have on there. So what we have is the 192.168.7.11 and .12. I entered those two values in there. Then once I see the target, I'm able to right click and then manage paths. So here's where you want to be able to set all your parameters and be able to get those paths set for the round robin. Let's go into our storage, add storage. We'll go to Dislon. We see the iSCSI target. Typically, I had some VMware issues today, but what you would see is that it would pull up the target that we just saw previously. So it could be something that's going on with my VMware server on those NICs, but I do have them set up on my VM kernels to be 7.230 and 231. And then what you would have is you would be able to see those paths coming in and you're using MPIO. Let's try it again. You may not be able to get it. I had some great difficulties today with this server. I was going to try to do an update to 5.0, but I don't have the patches downloaded yet for VMware 5.0, which you should probably have. There's an article written on our knowledge base about it. Let's see if we can bring it back again and try it. Yeah, it looks like the VMware is just having a hard time, but that's okay. I think everybody gets the point is when you're using MPIO, if we go back, is on the DSSB6. Let's go right in here. You want to set your proper NICs used for each of the VIPs. So you want to set 2 of the NICs. You can set more, and I've seen some cases where some people would use 2 bonds and then use the bonds for the virtual IP addresses and use bond with MPIO. That can work. In some cases, it's probably you're kind of mitigating the issue here and you're doubling up your efforts. Because if one NIC fails, if E3 were to fail, E5 will still transmit and receive the data from the initiator. So your I/O will continue. So at that point, you're okay. So really, to waste more NICs to do, let's say you would have to have 2 NICs for each bond, so there'd be a total of 4 NICs. So you'd have a bond 0 and a bond 1. Then the bond 0 and bond 1 would have their own virtual IP address. So in that case, you probably want to be able to really not waste that many NICs on doing that. You're just better off using 2 NICs for your MPIO instead of having multiple bonds and then create your MPIO from that. So pretty much that's how that works with the MPIO and the best practices for setting it up. Now, where I wanted to take everybody to the end here is if we go to our website, I want to show you where this documentation is and also about MPIO in our blog. If you go to Support Library, let's click on that. Here we go. And right here in Library, you'll see there's a how-to resources. We've made some changes on here, and we're going to be modifying it a lot. We're going to be adding some more on here. But if you go to OpenE, iSCSI, and MFS Auto Failover, this is where that document that I pulled up in the beginning has this information. You want to go to synchronous volume replication with failover, broadcast, or unicast, and here's where I was able to pull up the documentation. So this is where you might want to look at some of this information and for your records and how to set it up. Let's let it pull up a minute so everybody has a view on it. And that's where we were. So if you need to get to this document, that's where it's located at. Right here in our support page, you'll have it right in there in the library section. Also, all the webcasts and videos are stored in here, right below it, and I'll be releasing this one out in a couple of weeks. One last area I want to take everybody to. On the bottom, let me blow this up for everybody. You'll see a B here for blog. If you go to all the way down to the bottom and select number 4 on the 4th page, there's an article that's really important to read. Bonding versus MPIO explained. So we have some really good information, what we recommend with the bond, basically about link aggregation, control protocol, 802.3 AD, and etc. And of course the NIC bondings, also MPIO, how it works. So this is just a lot of information that might help you, and you can also forward to your customers. All right, everybody, thanks a lot for showing up. If there's any questions, please forward them to me, and I'll answer to you as soon as possible. And remember always to keep up to date. If you don't know where some of the information is, you can also click right here on your search engine and basically type, let's say, something for bonding, and you'll get information. You can sort it out via the website, and you can find a lot of information, or knowledge base. So we always update the latest and greatest for knowledge-based information. Here you can get information, the types of bonds, and other information that are probably useful to you. Especially when you see VMware errors, you start seeing a lot of information that you can drill right into if you need support. So that search engine tool is very helpful for a lot of people, and it has a lot of detailed information. Take care, everyone. I'll see you in a few weeks, and have a great holiday. Bye-bye.